Hi everyone, so the purpose of this video is to basically just help get some practice with paper 6 questions and just understand the way you should approach them. So the paper 6 is divided into two sections. So it's part A and part B. So over here you can see part A is an investigation and part B, which is later on, is modeling. So what I'm going to do in this video is go through the investigation section. Modeling will come in another video because they're quite distinct in the way you should approach them. And paper 6 just has some techniques you kind of need to get used to. And their way of marking it is really, really stingy. Like they'll give you 1 mark for doing like something that would usually give you 2 or 3 marks in maybe paper 4 or paper 2. So it's important that you're time efficient because although they do care about communication, which you should make clear, they do give a couple of marks for that. They do care a little bit more about the answer than other papers would, so it's very important to keep that in mind. So I'm going to be doing this right over here. Not going to do it under time conditions because we just want to get a feel for generally how you should do the questions. But obviously I'll be explaining it along the way, so you may want to do it a bit faster than I will. So obviously I'm going to write my candidate name. Always do that. Never get that step wrong. And you'll fill in your center number and candidate number, which will be given to you. All right, so let's get started. Okay, so investigation. So you're advised to spend no more than 45 minutes on this part. That's 50% of your time because this whole paper is 1.5 hours. So this is right spirals. And as you can see, it's 20 marks for 45 minutes, which means that they are really stingy. So the investigation is about the length of spirals drawn in a square coordinate grid given here. So a robot starts from 0, 0 and moves 1 unit to corner 1, turns right and moves 1 unit to corner 2, turns right, moves with 2. Okay, yes, it's just moving right, and adding units. And we're forming a spiral here. It's pretty clear to see how they want us to go about doing this. So the robot continues to turn and move in the same way. So by continuing the spiral, show that coordinate 10 is at 3, 3. All right, so we just have to continue the spiral. So what I recommend is definitely draw it out. Don't just start preempting the coordinates. And then even label it. So this is 0.6 here. Then you go down all the way here. 0.7. Then you move out. Oops. You move out here. Obviously, you'd be using a ruler. I'm doing this on an iPad, so there's no need for that. You can just draw it like this. So this is 0.9. Oops. And right over here, we have 0.10. And now let's check the coordinates. So actually it's 3 out wide and 3 up. So the coordinates of 0.10, I'm just going to remove those lines, otherwise it looks like it's part of the spiral. The coordinates of 0.10 are 3, 3. Is that what they wanted? Yes, they said 3, 3. So we got that question right. So the length of the spiral from 0, 0 to corner 4 is 6 units. Find the length of the spiral from 0, 0 to corner 10. All right, so 6 units to corner 4. So corner 4 is sitting over here. So let's count. So let me use a red pen for this. So 1, 2, 3, 4, 5, 6. Yep, it is 6 units. So if we count it in the same way, we should definitely get to corner 10 and get a value for it. So 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So in this question, you can just assume that they want the answer. So you can just literally count it like this, and it's fine. Because the point of the investigation, it kind of gets you warmed up with it. Later on, they'll expect you to put like proper like formulae and everything like that. All right, so we got 30 units as our answer. Oops. All right, let's write that down. So 30 units. Even though I don't think the units matters, just put it in because it says 6 units over here. You want to be as specific as possible and give as little room as possible to mark you down for it. All right, so use your spiral to complete this table. You know, I'm just looking at this table and we don't even need to use the spiral. Like, we know we can use it a little bit, like goes 1 up, then 1 to the right, then 2 down, then 2 to the left, then 3 up, then 3 to the right. So it's basically adding the same number twice each time. So we can use that principle for number 4. So if 3 is 1 plus 1 plus 2, 4 is going to be 1 plus 1 plus 2. And since every number is to be repeated twice, it'll be plus 2 again. Then for number 5, we'll have 1 plus 1 plus 2 plus 2. And then since 2 has been repeated twice already in 4, we'll add a 3. And as you can see, it fits along nicely with number 6, which adds another 3 to make it a pair. And number 7 adds the 4 because 3 has been repeated already. So number 8 will add the second 4. Like so. And actually, we can even just check it over here to make sure that we've actually written it out correctly. So 4 plus 4 is 8, plus 3 is 11, plus 3 is 14, plus 2 is 16, plus 2 is 18, plus 1 is 19, plus 1 is 20. So yes, this is correct. And while we're at it, we'll do it for number 5. We'll add them up. So 1 plus 1 plus 2 plus 2 plus 3 is 5, 7, 8, 9. So that's our answer for that one. And then for number 9, well, we just continue the pattern. So we go with the ones from number 8. So plus 3, plus 3, plus 4, plus 4. And then since 4 has been repeated twice, you add the 5. And honestly, we can just add 5 to the 20 here. We don't have to add them all up like this. So 20 plus 5 is 25. And then over here for number 10, we can tell that they added another 5 to pair it up. So 25 plus 5 is 30. And that's the complete table. Okay, moving on. So the table shows the length. Let me just check. I haven't missed anything here. So the table shows the length L of the spiral from 0, 0 to corner K, where K is an even number. So find a formula for n in terms of K. Okay, all we need to do is look at n versus K. So 1 to 2, and 2 to 4, 3 to 6, 4 to 8. It's very obvious where this is going. N is just half of K. So you can say that n is equal to K divided by 2. Let me write it over here. I don't know why I didn't write it over there in the first place. Let me get rid of some of these annotations. Okay, great. So use part A to show that the formula for the length L of the spiral from 0 to 0 is from 0, 0 to corner K is K over 4 times K plus 2. Okay, so all we need to do is we need to substitute K over 2 into this formula over here, which they've conveniently given. So since let me write this as L is equal to n times n plus 1. So therefore, L is equal to, and then I'm going to substitute K over 2 in here. K over 2 plus 1, which is equal to K over 4 plus K over 2. And, K squared over 4 plus K over 2. And we can factor out a K over 4 like they've done over here. So we get K over 4. So K over 4 goes into K squared over 4 K times. And then K over 4 goes into K over 2 times. So therefore, you would say as required. Let me just add L is equal to as required. So you would write this a lot nicer than I have. I've written it quite scrappily, honestly, but you get the idea. This is how you would approach it. You'd use part A. So make sure that you're always referring to the point to the part they're mentioning. Okay, so show that the formula gives the correct length of the spiral from 0, 0 to corner 14. This part is very easy. Just substitute 14 into the equation. So you get L is equal to 14 over 4 times 14 plus 2, which is equal to, so 14 over 4 is, it's 3.5. So that would be 7 over 2 times 16, which is equal to 7 times 8, which is equal to 56. So it says to show that it gives the correct length of the spiral from 0, 0 to corner 14. So we need to actually calculate what corner 14 is. So for corner 14, what we can just do is add some extra rows down here. Just to make sure we're proving this. Because corner 14 may not be 56. How do we know that it is? So if we just make the same columns. So you have 11, 12, 13, 14. So I'm not going to write this whole thing out, but I'm just going to say it's L of 10. So I'm just going to build off this answer over here. plus 6, since 5 has been paired up already. So that would be equal to 36. Therefore, this would be 11, L of 11 plus 6 as well, because that has to be paired up, which becomes 42. This is L of 12 plus 7, which is 49. And this is L of 13 plus 7 to pair up the 7, which gives us 56. So therefore, you could say something like, as illustrated in the table, this answer is correct. Another thing you could do is you could go back to the spiral and show that it goes to 56. So you'd have to draw all of the spiral to 14. Okay, so now we're going to move on to this question here. So when k is an even number, find an expression in terms of k for the length of the spiral from corner k minus 1 to corner k. So what I would do here is I would go back to the table and show and like identify a relationship that way. So k, from corner k minus 1 to corner k. So k is an even number. So let's go back to this table over here. So let's say k is 6. Well then k minus 1 is 5. And if we're looking at the difference over here, this difference is by 3. Let's go to a different one. So let's say we had k is equal to 10. And we go to k equals 9. Well, this difference over here is 5. So in this way, we can already see that 3 and 6 are linked because 3 is half of 6, and 5 and 10 are related because 5 is half of 10. So honestly, I would recommend using, like, if you have a focal point, like for example, I have of this table here, where you can see all the values, it makes it a lot easier. So you'd say L, oops, I'll write in the answer box, L is equal to k over 2. So from corner k to corner k plus 1, well, we can go back to the table and take a look over there. So k is an even number. If we go from 6 to 7, well, it goes from 12 to 16, which is plus 4. If we go from 8 to 9, then we're going from 20 to 25, which is plus 5. And if we look at the relationship between 9 and 5, 9 and 5, and we look at the relationship between 7 and, we look at the relationship between 8 and 5, because it's the even number. And we look at the relationship between 6 and 4, well, we know that this is 1 greater than the values we had before. 8 and 4 and 6 and 3 would have been the values we had if we had the previous scenario. But this is 1 higher. So we can say that this is k over 2 plus 1. So in this respect, we're getting really simple answers, and we're being very efficient about it. Plus 1. So using question 2b, find a formula in terms of k for the length L of the spiral from 0, 0 to corner k plus 1. So 2b. So that's over here. So k over 4 times k plus 2. So it's saying from 0, 0 to corner k plus 1. So what we can do is we can take this formula and add up this value over here, since it's going from k to k plus 1. So basically what we're doing is we're adding up the lengths from 0, 0 to k, and then from k to k plus 1. We're adding them up. So let's just do that. So what we have is k over 4 times k plus 2. L is equal to k over 4 times k plus 2 plus k over 2 plus 1, which is equal to k squared over 4 plus k over 2 plus k over 2 plus 1, which is equal to k squared over 4 plus k plus 1. And you can simplify it however you want, but that's the length. Okay, wait, let me just write here. K squared over 4 plus k plus 1. So use your formula to show the length of spiral from 0, 0 to corner 7 is 16. So corner 7, we know that k, the k value we're supposed to substitute in, is even, and it's saying k plus 1. So in this case, we're going to say that k plus 1 is equal to 7, so k must be 6, therefore. So if we substitute 6 into our equation, we get L is equal to 6 squared over 4 plus 6 plus 1, which is equal to 36 over 4 plus 6 plus 1, which is equal to 9 plus 6 plus 1, which is equal to 16, as required. I would always say as required because it shows that you're trying to show the value is this. Okay, so next one. So a corner on the spiral has coordinates x, y. Horizontal lengths on the spiral are added to give the total horizontal length. So I'm assuming by horizontal length, if we visualize this part over here of the spiral, well, the horizontal length would be this chunk over here, all the chunks that make up the horizontal portions. So I'm just looking at the way they've expressed it over here. So x coordinate 1. So the number of horizontal lengths is 1. For 2, it's 6. So I'm just going to take a look up here, what they might mean. So x coordinate 1 is over here. Wait, let me just put that. Let me erase everything over here. It's a bit cluttered. Okay. Let me use red. So x is equal to 1 is over here. That's the line it should be, rather. Yeah, that's the line. So you have to go up 1 and to the side 1 to get there, which is 1 horizontal length. However, if we want to get to x equals 2, which is this line over here, then you would need to go 1, 2, 3, 4, 5. You need to go to corner 6. And if we're looking at corner 6, it has, let me just use a different color for that. 1, 2, 3, 4, 5, 6 horizontal lengths. And that actually makes sense because if you looked at the table, it said 1 plus 2 plus 3 for the horizontal lengths to get to x equals 2. And the reason they've done that is because they've had a length of length 1, then they've had a length of length 2. So these are 2 units I've highlighted here, and then they've had a length 3 over there. So this is how you can like determine what they mean and therefore better understand the question. Always use the diagrams is my biggest advice. All right, so let's go back to the question, which is over here. So horizontal lengths of the spiral added to give the total horizontal length h, and they've given us many values of it. So we have to complete the table. It's pretty obvious though, like the trend here. We didn't even need to go to the diagram because it's just adding the next 2 numbers in the set. So if they've added 6 and 7, they're going to add 8 and 9 next. So we're going to have 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9. So it's x coordinate 5 is going to have a total horizontal length of 28 plus 8 plus 9, which is equal to 45. Okay, I'm just going to get rid of this over here. All right, so find a formula in terms of x for the total horizontal length of h of the spiral from 0, 0 to the corner with coordinates x, y. Okay, so you can do this in one of 2 ways. So one way would be to use your GDC and put the data into a spreadsheet, which will then compute it for you. However, because I personally don't like the GDC so much, I'm just gonna show you how you might do it if you wanted to do it manually. So the way you would do it is first construct a table with the knowledge that you have. So you're given the x coordinate and the total horizontal length. So 1, 2, 3, 4, you're given 5 data points. Okay, so the horizontal length when x is 1, then 6, then 15, 28, 45. So the first thing we should identify is, well, let's identify the difference. So what I mean is, well, to get from 1 to 6, you have to add 5. So let me use a red pen actually to make it clear. So plus 5. Then 6 to 15 is plus 9. 15 to 28 is plus 13. 28 to 45 is plus 17. So clearly there's a second difference since the first differences are not equal. So plus 5 to plus 9 is plus 4. Plus 9 to plus 13 is plus 4. Plus 13 to plus 17 is plus 4. Which means that the second difference is, so second difference equals 4. So we have a second difference, which means that we have a quadratic expression that we can determine from this. So the way so you know that it's in the form ax squared. I'm going to write this as h is equal to ax squared plus bx plus c, and we've determined a, b, and c. So from this, we've already determined a actually, because a is equal to the second difference over 2. So in this case, it's going to equal 4 over 2, which is equal to 2. So h is equal to 2x squared plus bx plus c at the moment. Now the next step is to actually make a separate column for 2x squared. So for 2x squared, the values using x would be 2, 8, 18, 32, and 50. Now what we would do next is, wait, let me just move this over here to the side. Oops, I think I moved it too far. Yeah, there, that's good. Now, the next thing you're going to do is you're going to make another row on the table. And that's going to be for 2x squared minus h. So if we do those values in, we're going to get 1, 2, 3, 4, 5. So clearly, this over here makes a sequence of plus n. Or rather plus x. Sorry, I keep referring to n because that's usually the sequence terminology. Plus x, plus x, plus x. And this gives us the first differences we need. So what we have here is that, I'm going to write the equation here. So 2x squared minus h is equal to x, as we've shown here using the different rows. So if we rearrange, we get h is equal to 2x squared minus x. And that's the equation. We can even test it with a couple of numbers, but we know this is correct. Okay, so for the second part, it's the total vertical length. And really, we do know that because the numbers are doubled, so if we go back over here, so we know the numbers are double. So there's up 1 and then horizontal 1. Then vertical 2, horizontal 2. Vertical 3, horizontal 3. Which means that the total vertical length is going to be the exact same as the horizontal length. And let's just write that down. So h is equal to v. So in this case, we're going to be able to say that x is equal to y in that respect. So if we do that, we get that v is equal to 2y squared minus y, because it's the exact same as the horizontal length, because they wanted it in terms of y. All right. Now, if we go to the next part, it says use your answers to part B and part C to show that a formula for the length L of the spiral from 0, 0 to corner K with coordinates x, y is L is equal to 2x times 2x minus 1. So what we can actually do is we are given the horizontal length, and we are also given the vertical length. If we add the two up, we get the total length. So L is equal to h plus v, which is equal to 2x squared minus x plus, sorry, let me just get rid of this real quick. I actually meant to write that x equals y would be here. X equals y, because in this case, x and y are different variables. So, sorry, I meant to write it here. So 2x squared minus x plus, and then since x equals y, 2x squared minus x. Because x and y will be the same values, considering that the horizontal and vertical lengths are the same. So this is equal to 4x squared minus 2x. And we can actually factor out 2x from this. We get 2x times 2x minus 1 as the length, which is correct. It's as required from what the question wanted. Okay, so for the final part of this question, it's the final part. The spiral has length 1,560 from 0, 0 to the corner with coordinates x, y. Use the formula in part I to find the value of x. So the formula in part I is this. So what we can say is 2x times 2x minus 1 is equal to the length of 1560, and solve for x. So we get 4x squared minus 2x is equal to 1560. If we divide by 2, we get 2x squared minus x is equal to 780. And then we rearrange to solve to set it to 0 to make it a quadratic form. Minus 780 is equal to 0. So we can now equate this quadratic to 0. And if we can do this one of two ways again. We can either substitute this into the quadratic formula, or we can use our GDC and plug this in to the graphing section of it. And in doing so, we can actually determine the roots of the equation by seeing when it contacts the x-axis. So I'm just substituting this curve into the GDC. Okay, now I've substituted in. Now I have to determine the roots of the equation. So there are going to be two roots of the equation since this is a quadratic equation. And the important thing to notice is that the spiral cannot have a negative value of x. So what we need to do is we need to find the positive value. So this graph clearly has a positive and negative value. So let's look for the 0 with the positive value. And I've just found it, and it looks like x is equal to 20. The other solution, which is, let me just find that. The other solution is x is equal to negative 19.5. But since x can't be negative, x equals 20 is our solution. X cannot be negative. Okay, so our final answer for this question is x is equal to 20. And there's the investigation part done. And honestly, we moved quite quickly through it. If we just identify the relationships that exist using diagrams and just trying to visually understand the question makes it a lot easier to go further with it. It's also about using previous justifications and observations you've made that the question is prompting you to consider in order to get the answer. So I think it's really important that you understand what's going on really early on by maybe drawing a diagram for yourself or filling in a diagram and then referring back to those previous parts, because those parts Cambridge has actually added to point you in the right direction. I think a lot of people don't look at the previous parts so much and they get a bit lost as to the direction of their whole investigation. So it's just important to keep in mind when you're doing that. So the modeling part, modeling part of paper 6 does require a lot more use of the GDC. So I recommend getting used to using it, unlike me, who has suffered trying to use it. But just approaching it in this systematic way will definitely help you. I'll make a video on how to approach the modeling section for next time. But hopefully this video helped.